Okay, so if you read the top, it talks about how we're going to be using substitution. And you've used substitution methods before in Algebra 1, where you take one thing and you insert it for the other. Anytime someone says plug in 4 into an equation, that technically is substitution. You're taking out the x, you're plugging in 4. So that's the background of that. The only difference is that we're using trig identities. So right now, if I were you, I would take out your yellow sheet. Do that now, okay? Just finish reviewing and kind of taking it all in with factoring. Does this look like something, like in the warm-up, you know, Jordan said, oh, move this over here. Does this look like something that would factor? Josh, you're shaking your head. No. Can I ask you why? Yeah, we have a cosine and a sine. Like, it's not going to be a trinomial. Do you have a GCF between a 9, a 12, and a 4? No. So I don't know. So I'm trying to teach you that when we get to the end of this unit and I just say solve and you're like, oh, what method am I going to use? How do I know? Well, I know that factoring is probably not going to work, okay? Then, algebra techniques. Do you remember in Algebra 1 when you had, like right now, and this was kind of on our weekly math, if I told you right now to solve x plus y equals 9, can you solve for x and get a numerical answer? No, because it's a two variable. So we're back to what Josh just said, which is these are kind of like two different variables, like cosine, sine. So we're out of luck. So what we're going to have to do is we are going to have to solve this by figuring out. It's almost like when you solve the systems of equations where you're figuring out like where do two lines cross back in 8th grade Algebra 1. We have to figure out, I got to get these in terms. The whole idea of substitution when you did lines is to get everything in terms of x or everything in terms of y. So you all know, here's my hint to you. We have to figure out, how do I get everything? Either this needs to become cosine squared of x, or this needs to become sine of x. Somehow, some way. We either need all sines, sine squareds, all cosine, cosine squareds. You with me? Like having all x's and x squareds or all y's and y squareds. So looking at your identities, does anybody have a suggestion for me? And it's okay if you don't. Notice this is no calculator. Is anybody thinking of something? That was like, yes.
Can't you substitute the pi-side identity for cosines and make it 1 minus sine squared?
Okay. I'm going to write this down so you can all hear her, and let's try it. We're not out anything. Remember, sometimes this is trial and error. Okay, so here we go. So she said, leave the left side alone. Can you all see that okay up there? Okay, I don't usually use this, so if I need to turn off the lights or something, let me know. Do you realize that cosine squared of x, Emily is telling us, hey, go to your pi-fag identities. What's cosine squared of x equal to, everybody? 1 minus sine squared of x. So what happens is she has taken out this and she has put in its equivalent. Now, what does your gut instinct tell you to do now? Now, I will tell you she's correct. I think that's one of the easiest ways to do this problem. So what is your gut instinct? At your seat now, without anybody telling you, what do you think you might want to do? Distribute. So here we go. 9 minus 12 times the sine of x. Let's distribute this 4. Okay. Ooh. You're thinking, that looks even uglier. Now, you know from quadratic relationships that you're never going to get a sine squared of x isolated and a sine of x at the same time. So back when we solved quadratics, we got everything on one side, didn't we? So let's do that now. So right now I want you to move all this stuff, okay? So we're going to subtract 4 from both sides, and I'm going to subtract this. So I'm going to add 4 sine squared x, to both sides, and then I'm going to put in order, almost like in, when we do x squared plus x constant at the end, like we did in Algebra 2. So I'm going to write this as 4 sine squared x minus 12 sine of x plus 5 equals 0. Okay. Where would we go from here? Factor. Let's see if this factors. So if we could factor 4x squared minus 12x plus 5 into this, and I'm going to move this up, I know that this then factors, into 2 sine of x minus 5 times the quantity of 2 sine of x minus 1 equals 0. Voila. Now, I'm going to do this one with you, start to finish, so we have that, but here we go. By the zero product property, the sine of x either has to equal 5/2 or the sine of x equals positive 1/2. Now let me ask you a question. What's 5/2 equal to? 1.5. Does our range of our parent function, what's our range of our parent function? Remember our graph? So is this possible? I'm just going, okay, we're done with that side. That was easy. Now, when will the sine of an angle equal 1/2? That's what I need you to find right now on your own. So if you've got to think back unit circle, what's going to give you 1/2? So remember, the sine is, you got to think y coordinate. The y coordinate of what degree, everyone, is 1/2? That's 30 degrees, right? But we're going to write a radian, so one of our answers is pi over 6. We're going to have 2 answers, because in all students take calculus, sine is also positive in the second quadrant. So what's that 30 degree? If 30 degrees is our reference angle, what angle or radian measure is over there? 5 pi over 6. And so in red, if this is where you're struggling, that resorts back to like 12 weeks ago, okay? Do y'all see what we did here? Okay, I'm going to have you try 2 on your own. Okay. Not sure if you're catching on. And by the way, not every time, and I don't want you to think, it's not every time you're going to use a Pythag identity. It could be the quotient identity, or just as easy as, oh, secant 1 over, cosine. But I don't know that we would want to do that just because we have 2 different kind of types. It's almost like having x and y. So anybody have a suggestion for me of what they tried? A Pythag identity? Who used a Pythag identity? Okay. So can someone tell me what they did? Anyone volunteer? So poor Madison back there is not like, why is she talking to me? Bella, thank you. What do you think here? Okay, good. Let's see how that helps us. And once again, it's okay if you start it and you're like, whoa, this doesn't work, okay? So she replaced tangent squared x with its equivalent secant squared, oops, I forgot my x, my bad, minus 1, okay? Now, let's distribute. Let's do exactly what we did kind of in problem number 1. So we have 2 secant squared x minus 2, because we're distributing, and then everything else is the same. And then we can combine like terms, right? So we have 2 secant squared x minus 3 secant x plus 1. Now, once again, this is not any different than if you were trying to factor this baby right here. Now, like I said, I'm not going to do any more factoring for you because we kind of reviewed that, but some of you are catching on to, wait a minute. A 2x and an x, what would have to go right here and here to give us this end result? -1 and -1. Well, let's check. 2x squared minus 2x minus x, okay, that works, plus 1. Good. So once again, that means that I can factor and write it, sorry, not trying to make you seasick here, but this is going to factor into 2 secant of x minus 1 times the secant of x minus 1. So don't let that secant scare you. And then we solve, okay? So this is either going to equal 0 or this by the zero product property. So the secant of x is going to be 1/2, or the secant of x is going to be 1. Well, note to self, I don't deal with secant very well in my life, so I know that the reciprocal of secant is cosine of x, so this reciprocal is 2. And then the cosine of x, the reciprocal of 1 is 1. Well, we talked about this in the warm-up today. Nope, never going to happen, because the range of the parent cosine graph is from -1 to 1. And then when is the cosine of x equal to 1? What degree measures, in radians, I should say, what angle measures, not degree? When is the x coordinate 1? 0, good. 0 pi, you can write 0. So 0 radians and 2 pi radians, and you're done. Okay? All right, I want you to do one more. I want you to do number 3. I want you to tackle that. I'm going to push. All right, so number 3. Ooh. Are we going to be able to use a Pythag identity, do you think? Okay, so I have a yes, so maybe that's one way you did it. I personally did not use a Pythag identity. It doesn't mean you're wrong, okay, because you totally could take out, well, is there a Pythag identity that relates tangent and cosine? That might get a little sticky. So, any suggestions? My first spell, anything? You did a Pythag identity? What identity did you use? Just being nosy.
Tangent to secant minus 1.
Okay, so then did you change cosine squared?
I'm not sure if I'm allowed to do what I did.
Okay.
But then I subtracted the 1, or I added a 1 to both sides.
Okay.
And it's divided by 4, and it's got cosine squared times secant squared equals 1, and then 1 equals 1.
Okay.
I'm not sure if I'm allowed to do that yet.
Okay. Well, so we're not necessarily verifying we're solving, but let's see. Hold on. Don't erase anything just yet. Let's see. I did get there are 4 answers to this. So that might tell you, and not that I gave you enough time to even finish this, but let's think about it for a minute, okay? Knowing that I'm multiplying, and this is where these are not easy, so I don't want you to feel like I'm not going to give you 40 of these and be like, go for it, because they do take time even just to get started. But do you remember, and this will be on your quiz, this part next week, is where we talked about maybe what's the first thing? One of the things says, like, can you write things in terms of sine or cosine? So can we write tangent squared in terms of sine or cosine? Okay, let's try that. Like I said, and this is why we're doing this together, because no one's expecting you to be like, oh, okay, that's what I would do. What is tangent squared of x equal to? Good. Sine squared x over, cosine squared of x. Now, do you immediately see what that did for you? What cancels? Cosine squared of x. Gone. Okay? So what we now have is 4 times sine squared x equals 3. Does this look like we're gonna solve this by